Okay, let's find a bunch of distances now in some more meaningful situations. Okay. Number 1 says use the contour map to answer these questions. Okay. Done. So before I begin, I just want to look at a few of these things. I notice this is going up by tens. It looks like these measurements are in, oh, if that's too, very interesting. Are these feet of elevation, I'm guessing? Okay. So, let's see what we've got. And a horizontal is 200 feet of that length. Got it. Part A, write down the vertical heights of points M and N. Where are those? Points M, point N. Vertical height. How tall on the mountain is this? So I'm noticing, okay, so here's the side view of the mountain if you were just gazing at it from the horizon. And here's the vertical view if you were in a helicopter looking down at it. And meaning this would be the peak and then it would go down, right? And this would be another peak and it would go down. And here's point M, and they're saying that that is at the 50 feet elevation marker. So at 50 height. And here is point N, right? And that is going along this 10 feet of elevation marker. Yeah? So the vertical height of point M, 50 feet high. If you are at this point on the mountain, you are 50 feet probably above sea level is my guess. But anyway, point of elevation is M's vertical elevation is 50 feet up. And N's elevation or vertical height is 10 feet up. Oopsie, feet. 10 feet up. There. Got it. Find the vertical distance between the heights. Oh, the vertical distance between the two. Okay, so they're looking for the change. Or, right, if you started at point N and you're going up, what is the difference between the two heights? Okay, well, you only actually went up 40 feet, right? So the distance, the vertical distance between these heights is 40 feet. Okay, use the scale to find the horizontal distance between M and N. Right. I am going to need to write that scale on a piece of scratch paper. Bring it down. Okay, so here's my scratch paper. And I know that this is 200 feet, but I'm actually going to draw the whole darn thing. Let's see if I can copy this. Yeah? What are these, like 50s? Because this is 200 feet. So I go down here and, oh, you know what? I can do it right here. Well, la-di-da, like 200 feet, yeah, is the distance between these. That's the horizontal distance. Okay, so the horizontal distance between M and N, we just measured that. That was actually 200 feet. Got it. Finally, you can compute the actual distance between these 2 points along the mountain. Please do so. Right on. First, that's the first please in a math class. Let's see. Because at the end of the day, what we're doing here is we are building ourselves this right triangle. Yeah, essentially, we're using this right triangle to estimate this distance. And we just said that the vertical height, oopsie, my bad, that the vertical height of this is 40. And we just said that the horizontal distance is 200. Okay, clearly this triangle is not exactly the scale. Okay, because this is 5 times bigger than that, but I'm not going to get into that. So their vertical scale is not actually proportional to their horizontal scale, just FYI. It's a little bit distorted in terms of equal scales, right? This is by tens and this is by 50s, but you know, sometimes we have to distort it to fit it to the page. Find the actual distance between M and N. Well, we got this. We've done it several times now. So let's see. We've got the two legs. So 40 squared plus 200 squared equals D squared. 40 squared, was that 1600? Yes. And 200 squared, 200 200s. Is that 40,000? Yes. That equals D squared. Add the two. Ooh, I'm very popular. And so D squared equals 41,600. And then we're going to need to take the, oopsie, you can't see what I'm doing. And then we're going to need to take the square root of that. So take the square root. Oops, it's not equal. It's approximate. We have to approximate this. 203, ooh, 0.96. Yeah, I'm going to round that to 204. Feet. Feet. Everything's in feet here, and that is a really important thing to mention. Okay, so this is about 204 feet of hiking. So you're going up and you're going over, and so you're going up this mountain, and that is a total of 204 feet about of actual hiking. Nice. Okay, a right triangle has a hypotenuse of 18 miles and a side length of 3 miles. Find the third side. I'm going to have to draw. Okay, I'm just going to make a quick drawing here. Hypotenuse of 18 and a side of 3. Ooh. I'm just going to change every mile to a centimeter. So side length of 3. 1, 2, 3. 3 miles and hypotenuse of 18. Okay, so believe it or not, I'm going to do this horizontal because it says it's a right triangle. But I don't know how long this side is, so I'm just going to build a very long what if. Oh man, 18 miles. This only goes up to 15. Oh, shenanigans. Okay. Radio. Okay, so now we're going to have to play pretend. Okay, I see. This is definitely not exactly the triangle that we're building. But we're just going to say, hypothetically, so this is actually a shorter and more like a skinnier triangle. But nonetheless, here we go. Let's use these to find this third side, yeah? Well, that is actually the longest side because here is our right angle. So this is saying 3 squared plus, I'm going to turn this into the blue side that it usually was for all the other problems. 3 squared plus we don't know squared, I'm going to call that side B, equals 18 squared, because 18 is now the longest side. So we have to be careful about where we put these. 18 is actually the longest because it's the hypotenuse. Okay, so that means, 3 squared is 9. 9 plus b squared is equal to, insert large number here, 18 squared is 324. That means b squared has to be equal to, okay, 324 take away 9 is 315. And then last but not least, we take the square root of it. Okay, so take the square root of that. Ooh. So the third side length is, I'm going to write it down here. Find the third side length. About 17.7 miles. And I got that from taking the square root of 315. Okay, voila. So this is a totally map situation if I knew any better. I mean, I guess it could be something else like the location of a plane in the sky, all kinds of things, but nonetheless. A rectangular television has a diagonal of 26 inches. Okay. Okay. Whatever. That's our TV. Okay. Diagonal of 26. Got it. Which is how they describe it in the store. If the height of the TV is 15, so 15 inches, 26 inches, how wide is the TV? Okay, we got this. I feel like this is very similar to this situation where we are given this 15 is actually one of the shorter side lengths and 26 is the longest side length. So 15 squared plus b squared is equal to 26 squared, because that's the diagonal, which is also the hypotenuse here. Okay, 15 squared is 225. So 225 plus b squared is equal to, okay, 26 squared is 676. B squared is equal to, okay, what's the difference between those two? 451. And now we need to take the square root of that. Because it's definitely not 451 inches. That's absurd. Yeah? But I've got to tell you that most people just accidentally forget to take the square root at the end. Or some people accidentally take square roots before we get there. But that's not the case. So make sure you do the order of operations right. Square things, subtract things, square root. Subtract or add, I guess, depending on which ones we know. So B, the width, is approximately 21.2 inches in width. Got it. Find the distance between these two very precise, randomly located coordinate pairs. Now this to me looks like longitude and latitude. So let's do it. Okay, the distance formula said that the distance equals the square root change in y squared plus change in x squared. And So first find the change, then square, then add, then square root. Okay. Similar to the Pythagorean. Well, the Pythagorean. How far apart are these y values? Well, subtraction gets us the difference. Okay, so 1.12 minus negative 3.55. Those are 4.67 apart. Okay, so the y's are 4.67 apart. The x's are going to be, I don't know, 9-ish. So let's see. So it doesn't, if you end up with a negative here, you just turn it into a positive. Or if you have a negative, I'm actually going to write it as the negative here. Negative 6.41 minus 2.89. That difference is negative 9. I definitely put this in wrong, did I? Nope, I typed it in right, is 9.3. But notice when it's negative, I'm very careful to keep those parentheses for the change. You know what, might as well do it for both, just to be careful, yeah? So the change in y, I took 1.12, and I found the difference between it and negative 3.55, subtraction. The change in x's, I put negative 6.41 minus 2.89, and I got negative 9.3. But now I need to square. So is equal to the square root 4.67 squared. 21.8089 negative 9.3 squared is 86, positive by the way, 86.49. Because a negative times a negative is a positive. Okay, I'm going to go ahead and add those two numbers together, and that is equal to the square root of 108.2989, and that I'm going to take the square root of, and I get approximately 10.4. Find the distance between these 2 points, about 10.4 units, whether those are inches, centimeters, millimeters, kilometers, miles, I don't know, because it wasn't indicated what the units are. So 10.4 units about. Okay, so what did we learn? I hope you learned something. This. Well, we apply the Pythagorean theorem to right triangles, and we have to be able to do that because that's the cornerstone in developing the distance formula. And using this should really maybe say develop and use the distance formula, yeah? So if we understand one, we understand the other, and in order to do this, right, we really just kept applying the Pythagorean theorem to different scenarios of right triangles. So here's a couple of different scenarios of right triangles. Here's another one, right? And all of that boils down to the distance.